Hello, everybody, and welcome to today's Hubble Hangout. My name is Tony Darnell. I work at the Space Telescope Science Institute, and it is great. We have a really interesting hangout planned. I think we're going to be talking about the history of the Hubble Space Telescope. Before I introduce my guest, I just want to say I better warn you, we've been having some technical glitches at the start of this broadcast. So if we start freezing and stuff, I think it's an issue with the Google Hangout system. So we hope you'll be apologies in advance if it gets really, really bad. So just wanted to say that.
Call for a Hubble servicing mission.
Yes, that's right. That's right. So, as many of you know, Hubble has been in orbit for 24 years now, taking data, and we're approaching it's approaching its 25th year. And this hangout is going to be the first in a series of hangouts that we do to help celebrate Hubble's 25 years in space. So this is the first one of those hangouts in that series. So we are excited to be able to offer this to you. If you want to, we hope you're going to give us comments and questions. You can do it on the YouTube and G+ event pages. We're monitoring those comments. You could also use the Q&A app that's on the video screen itself, as well as tweeting with the Hubble Hangout hashtag. So we hope to see some comments and questions for you, and we will look at. I'll read them out as the hangout progresses. So our guest today is we have some guys from the Goddard Space Flight Center. We have Russ Werneth. He's the former EVA manager for Hubble, and he is now joining us to talk about some of his experiences with the Hubble Space Telescope. We also have Dr. Kenneth Carpenter. He is the operations project scientist for Hubble at Goddard. Welcome, guys.
Great to be here. Thanks, Tony.
Also joining me, as always, Dr. Carol Christian and Scott Lewis. Scott Lewis is driving our internet for us. Thank you, guys. All right, so
today. The internet's driving itself, apparently.
I know. I really hope the doesn't get too bad. So, yeah. So Hubble's been around for a while. I want to start at the very beginning, and I might mention that I think Carol, Scott, and I are going to be doing more of these Hubble Hangouts on the history part of it anyway, too. So I don't think that we're going to plan on trying to cover every single bit of the history of Hubble, but we are going to get to the focus primarily on the early parts. And so I guess, Ken, let me start with you. I'd like to ask, where did the idea of putting a telescope in orbit come from? Where did it originate?
Actually, the story for this goes back quite a way. I think the earliest suggestions of doing an orbiting space telescope were back in the 1920s, actually. There was a man named who wrote an article describing the possibility of launching an observatory into space on a rocket. He was more into rockets, just like Robert Goddard, but he was also
out again. I can see that already.
Could you hear that, or did it all disappear?
It froze up again, yeah.
It all just froze up. I'm sorry.
Okay. Well, basically, I said that in 1923, a guy named Herman Oberth actually wrote about launching an observatory into space on a rocket. He was looking for applications of rockets that they were starting to play around with. And 1946 was probably the seminal article about a space telescope. A professor named Lyman Spitzer at Princeton wrote for Project RAND, which was a think tank back in the 1940s, and he wrote an article about the advantages of putting an astronomical telescope into space, noting that you wouldn't be looking through the atmosphere, which blurs things out from the ground, noting you could see a broader wavelength of colors if you weren't looking through the atmosphere, and that you had a darker background. So that's really sort of the beginning of the idea of an HST. So way back in 1946, through the 60s, there were various conversations about Hubble in the 60s.
Oh, you're muted. Oh.
Okay, where people talked about what size telescope they might do, and it actually started out as a 4-meter telescope, the idea of launching it on a Saturn V rocket. So it was 4 meters on a Saturn rocket instead of 2.5 meters in the space shuttle, and we actually got there in pieces. Basically, in 1968, there was something called the Large Space Telescope, the LST, which was supposed to be a 3-meter telescope. And that went along for a couple of years. in 1974, basically all funding got cut by Congress, and there was a regrouping. People got together and worked with Congress and various politicians and the astronomical community to figure out what is reasonable. And out of that came that we know today, the 2.5 meters flown on the shuttle, and a mode that it could be serviced every 3 to 5 years.
So the idea for I'm glad you brought up a good point about the atmosphere and being able to while the atmosphere does protect the sun and radiation, it blocks out some valuable wavelengths that we'd like to be able to see in astronomy, and so a strong case. And was the process back then similar to what it is now? Now we have these things called decadal, so not the most, and they are all ranked in order of priorities, or was it getting up on a soapbox and saying, I want a Hubble Space, I want a space telescope, I want a space. Hello?
Well, it wasn't.
Yeah,
you were breaking up, but there weren't the regular every 10-year studies that you were talking about. But there was a lot of both with the astronomical community and with Congress and the president to try to get new projects started.
In those early days, cost had to have been an issue on a cost versus the other things NASA was doing at the
Certainly, cost was a huge issue because people knew that Hubble wouldn't be cheap, and that's one reason it went from 4 meters down to 3 meters down to 2.5 meters, was to try to control the cost. But some kind of science that you would do with an orbiting telescope that would look at high energy events in the cosmos, wanted to launch an X-ray satellite. The UV optical community, which is served by Hubble, wanted Hubble to do their kind of science. So there was trade-offs about which kind of telescope would be launched first, one would cost versus the other. So it was always a constant pressure to do it as cheaply as you could, but make sure it was big enough to do the science that you had proposed. Otherwise, it wouldn't be worth anything.
Guys, I need to apologize to everyone about this connection. It's not anything we can do about it, but I do want to apologize for the quality. We all keep cutting out, so please bear with us, and we'll try to do the best we can with it. Russ, let me ask you let me ask you a quick question here. In the early days of the design, did the design of the telescope, as you could tell, did it change much from the early days? I mean, was it what were some of the factors that went into designing the Hubble Space Telescope?
The things that changed were, first on the software side, because of delays, we were able to make changes relative to software. Also, battery improvements. So I think they were the two big areas during that time, and during the delays caused by different reasons, that we essentially bought some time, although we paid for it because it added total cost, and allowed some improvements during that development stage.
Isn't it true that when you're building a spacecraft, you have to kind of design it with technology that's already proven and reliable at the time you're building it, and over the course of the construction of the spacecraft, like I'm thinking, for example, detector design. If you're building a camera and you want to have a certain detector in it, you're building it in 1985, you know, and then you're not going to have it finished for another 7 or 8 years. Well, CCDs and detectors have gotten a lot better over that time scale. You have to kind of, they're almost obsolete from the beginning, aren't they? Spacecraft.
That's pretty much true, and it also brings out the advantage of Hubble Space Telescope, in that the initial concept was that as we had new technology or things needed repair, we could go back to it. So during our servicing missions, the 5 servicing missions that we had, we essentially left the new telescope because we repaired things and we put in that new technology that we didn't know back when Hubble was first designed, or the previous servicing mission. So that points out one of the great advantages of Hubble.
Oh, so when I introduced you, your title was EVA manager for Hubble. Can you just give me some? What is that? What does an EVA manager do?
Well, of course, in NASA we have to talk in acronyms. So, EVA stands for extravehicular activity, and extravehicular activity is a fancy word for spacewalks.
Getting outside.
Getting outside. Back when Neil Armstrong walked on the moon, certainly he got out, walked on the moon. That was an EVA. When the astronauts got out of the shuttle, which had met up with Hubble, and they went outside to do what we had planned for them to do. They were doing EVAs because they were in their astronaut suits and they were outside of the environment of the shuttle. So the EVA manager from the payload side, from Hubble Space Telescope at Goddard Space Flight Center, was in charge of developing all the special tools that were needed to meet the requirements for that particular mission, to come up with procedures and working with Johnson Space Center and build those tools, build the procedures, and to do our part in training for what the astronauts had to do for all the EVA days that we had planned for them.
Okay, so we know from early on that I mean, anybody who knows Hubble knows it was designed to be serviced by shuttles. It was put up there by a shuttle. Was that always the case? And I'm not sure who is better able to answer this question, so I'm going to put it to both Ken and Russ, and you guys can decide. Was it always the case that Hubble was going to be an integral part of the shuttle mission, or was there ever a time when they were going to just use a rocket or something like that to get it up in space?
I can start on that if you want, and then Russ,
okay,
you can comment further.
Okay, go ahead.
Yeah, originally the concept for HST was for an orbiting space telescope was to launch it on a Saturn V, so the moon rocket that launched the Apollo missions.
Yeah, because there were some left over after the Apollo missions, right? After the Apollo program ended.
That's right, and some of them are in museums nowadays.
Yeah, yeah, now they're
get some fuel in those guys, maybe they'd still go,
Very true.
One of the things I discovered in the last couple of months when looking back at the older history of Hubble is one of the early concepts actually had a crew person on board helping to run the telescope.
Oh, now that would be cool. I would sign up for that job.
I don't know that they ever followed this up. I don't know, Scott, can you get that graphic up?
I love this idea. I remember reading about this. I was like, whoa, that's amazing. And there's all kinds of documentation and arguments about what, whether that's feasible. And this is when they're going to send film canisters down, right?
Yeah, exactly. So if you can see the graphic now, you see in the back end on the right side of the telescope behind the mirror.
Scott has it up now.
There's actually a person floating sort of horizontally above the instrumentation. And the concept was exactly as you said, Carol. They were going to go and actually use film. The person would then take film out of the cameras, roll it up, and then somehow get it back to the Earth. I never actually saw an explanation of how in the world they were planning to.
But they were going to have Russ pick up the film.
Run
out there and pick up the film.
That's
they'd
why
have to find a way to support.
That's why I was late to get here for the hangout.
Exactly.
I think one of the reasons they went away from that idea, in addition to all the complications in trying to support life up there, was the contamination issue, because there would be a lot of contaminants coming out of even a single person in the background. And one of the things we've done very carefully over the years is to try to keep all possible contaminations off the surfaces of the mirrors and the detectors, because it would hinder their people out of the immediate equation. Actually, was a very positive thing.
Although I'd say that would be, I mean, beyond being an astronaut, which would be an awesome job, being the person inside the Hubble Space Telescope, I think would be the perfect job. Like, sign me up. That would be amazing.
I couldn't agree more. I think it's
what do you do? Oh, I work a telescope in space. That's what I do.
And that was supposed to be a shirt-sleeve environment. It wasn't big astronaut clunky suit or anything. It was supposed to be a pressurized cabin, so you could go there in your YouTube T-shirt and work in the lark.
I could do a Hubble hangout from space, from Hubble. That would.
That would be. I'd watch that. That'd be great. Okay.
You can literally look through Hubble, which no one's ever really done. You know, we do it
Yeah.
all with remote detectors now.
Oh
That's
man,
true.
that would my other show, the Virtual Star Party, would add more depth. Oh wow, never mind. You're exploding my brain with possibilities of this thing that never happened.
Maybe we should do that anyway. We should do it in the future anyway. Have it in Earth orbit. But what about? Well, that's a different topic. I won't go there. I was going to ask about the space station, but that's off topic. So, the decision was made at some point that it was going to go in the shuttle. What were the circumstances of that? What was the final driver for saying, "Hey, no, we're not doing this. No shirt sleeve environment. No launching on a Saturn V. We're using the shuttle." What was the driver for that? Russ, is that something you can comment on?
I believe I can. The paths for the space shuttle and Hubble Space Telescope merged about that time.
About what time?
Within that time frame, I'd say within the 70s.
Okay, so we're talking 70s still.
Yes. Actually, the funding for Hubble, or the authorization from Congress, came out in about 1977. And of course, the first shuttle launch was in '81. So around the time when proponents for each of these programs were trying to get approval for Hubble and for the shuttle, with the shuttle doing Earth orbit to get up and back to Hubble, which would be in low Earth orbit, it made sense to make certain that Hubble was designed to fit in, latch in, and be able to be. So those two programs, how Hubble came about,
so
being on the shuttle.
So that would turn out to be a very pivotal decision to make the shuttle be able to go up and get this thing later in its history, but it sounds like, you know, that I'm sorry, folks. It looks like I think we've identified that it's an infrastructure issue with the Google stuff, and it's still happening here and there intermittently. And my apologies on that. So the decision to actually service it would turn out to be an important one. If we had launched it with the Saturn V, probably, well, maybe, I don't know. Could we have gone up and serviced it with the shuttle anyway if we had launched it with the Saturn V?
We could have, if we had planned ahead, as we would have if that were to be the plan.
Okay.
To have fixtures on it as what the interfaces were. Yes, we could do that if it were launched by another vehicle.
Okay, so we've made decisions. We're going to have a space telescope. It's going to go in the.
Wait.
I'm sorry.
I have a question. So from the timeline I'm understanding from Ken and Russ, it sounds like there was a long period of time deciding to do a space telescope, but then it was pretty quick to switch for the launch vehicle. I mean, it was like over 5 to 10 years. Is that right? I mean, that's quick in the space arena. Is that right?
I think so. There was a huge push in the mid-'70s, I think, by the astronomical community. It was led by involved in the early push for the telescope, and John Bacall, who also happened to be at Princeton. They managed to get the community together, a group of politicians and public together to actually support this idea, and then they worked with manned spaceflight on the shuttle and sort of got everybody converged very fastly, with all the different pieces coming together. And the fact that they brought the price down at the same time, I think, is what it allowed it to finally move forward and gain the traction that it hadn't had.
Okay, cool. Thanks.
Yeah, thank you. Okay, so we got it in shuttle bay. It's going to be it's constrained, obviously, by the size, what the shuttle can do. So the design was primarily constrained by the size of the shuttle bay. But if I remember right, Russ, didn't it take up everything in there?
Can you ask that again? You broke up.
Oh, I did. Constrained by the size of the shuttle bay. Am I still breaking? breaking up, then I think I remember it taking up every square empty space in the shuttle bay itself. Is that true?
That's pretty much true. We had, of course, a carrier to hold on to it that was in the bay, and at that time we were rolled up, and then each mast of the solar array was folded up against the side, and that's about all that would fit in that shuttle bay. And to get it deployed, that's all we need.
So as the way NASA does things is it always uses contractors. It did that with Apollo, and it does it with it's doing it now with the James Webb Space Telescope. Who built this thing? What was the primary contractor for the Hubble Space Telescope?
Primary contractor for the structure was Lockheed Martin out in Sunnyvale, California. There were many other contractors that were building scientific instruments, various parts, solar arrays, and the mirror. So there were many, many contractors, but for the main part of Hubble, it was Lockheed Martin.
And Scott has an image up of some of the various integration or building phases of the telescope, which is kind of cool. So it's neat to see that. So it was built, it looks like, in the 80s. How long did it take to build? Anybody? Kenneth?
Well, it was pretty much, well, it was ready to go in January of '86 and would have gone if it had not been for the Challenger accident, which delayed us another 4 years into the actual launch in 1990. So, you know, if you figure it started basically in the late 70s, you're talking, what,
about 8 years or so. So.
And you know, we did make further improvements and whatever between '86 and '90. When
like what? Launched. What were some of the things that were changed? Do you know?
You were able to update detectors, for instance, on some of the instruments, either the camera or even the spectrographs, where you could get higher sensitivity, see fainter objects on the sky. We were able to improve the ground system software a lot to improve the scheduling and the data reduction and archiving of material. So basically, you know, because we had the extra time, people just kept working and improving things, and what went to orbit and what was in the ground system at launch was actually substantially better, just because we had the luxury of time that you don't have in a rushed launch schedule.
Yeah, it sounds that's kind of a silver lining out of a bad situation. So that yes, good. Okay. Well, so let's just go ahead and talk briefly about. So it launched in 1990. It goes up. We turn it on. And we start looking through it, and the images are a little bit fuzzy. One of the contractors, the people that built the mirror, Perkin-Elmer, had introduced an aberration into the primary mirror. Did that affect the science very much, Ken?
Well, it certainly did. Because the telescope wasn't as well focused due to the aberration, you couldn't get the resolution between objects on the sky that you were hoping to get otherwise, and the sensitivity of the various instruments went down because there was less light falling on a given pixel on the detectors. One bright spot there, and that was pretty much the case for the imaging instruments. Some of the performance there was recovered in the end by some after-the-fact software reduction, which packed the light back in to a smaller space on the image. But one thing that sometimes gets forgotten is that the spectrographs, which usually have a little opening, a slit at the front end to narrow the beam of light coming in, they could still perform at their original specification level in terms of resolution and how well they could separate colors or places on the sky because of that narrow slit. Now, you did lose light because the image wasn't as well focused. Some of the light didn't make it through the slit. So you had to expose longer. So in the case of the spectrographs, the quality of the data, you could get the same quality of the data as long as you were getting it. So you could do fewer objects, but you could still do the same quality science. And that's something that was a little harder to do with the imagers until we put the corrective optics in place.
Right, and I think that's amazing. The cleverness that was in those years, and then so that brings us to some servicing missions. Then we had found our need for the first one. You want to comment on that, Russ?
Can I back up a minute?
Oh yeah.
I'd like to add what to what Ken said.
By all means.
I like to say that the mirror was ground with a very high technology process, absolutely perfectly, to the wrong spec.
They did it. They did it the way it was supposed to be done, just with the wrong instructions, the wrong recipe.
Right.
And the amount that it was off, it was too flat around the outside edge of this 2.4 meter mirror by 1/50th the diameter of a piece of human hair. But in space optics, it doesn't take much, and that was a tremendous problem. But like Ken said, anything that was using the center part of the mirror for 3 years or so, we did get pretty good optics back. But again, that leads into your question about servicing missions.
Right. So how many were there, Russ? How many altogether? How many servicing missions were there for Hubble?
Well, we went from SM1, servicing mission 1, up to SM4.
Scott has a graphic up.
Ah, good. So that sounds like we had 4 servicing missions. However, we really had 5.
Oh, really?
For SM3, because we were coming up on a potential Y2K problem at the end of 1999, we had a requirement to get up there, get back, be safe on the ground by December 31st, 1999.
I did not know that.
That's
yeah. We were. Everybody was sweating bullets. Are you kidding?
Remember that?
Oh my gosh! Yeah.
Oh, I had no idea. So, well, they were afraid it was going to fall out of the sky, or what?
Oh yeah. Oh,
So
yeah.
Because gravity and momentum stops with Y2K.
Yeah, exactly. Exactly.
That's what we heard.
So NASA had a requirement. Everybody's on the ground
Yeah.
during that when the clocks turn over. That's funny.
Yes.
I did not know that.
Now,
So
we had, from the servicing viewpoint, from the EVA viewpoint, we had a lot on our plate in what originally was called SM3. So in order that nobody forgot that we couldn't do all of that, since we had a new requirement to be back on the ground before New Year's Eve 2000, we broke it up into 2 servicing missions. So we have a 3A and a 3B. So in answer to your question, the total number of servicing missions was 5, but the last one was SM4 in 2009.
Oh, that's hilarious.
There was actually a second reason why the servicing mission 3 was split into 2, and that's because we had an increasing number of gyro failures going into that mission, and eventually ran out of sufficient gyros to operate the mission. So we did what's called a call-up mission, which has always been an option. We had the option to tell manned spaceflight, we need an emergency mission now to service Hubble because something's gone wrong. So we said we're going to exercise that option now. We're just going to do the gyros, which are absolutely critical, and a few other things that are ready to go, like the advanced computer and the Fine Guidance Center. And we're going to before 2000 and get HST back into operation.
If you look at the graphic, you can see the things that are installed, and of course the astronomers had to wait for 3B to get their instrument, but it was more important to put these technical instrumentation in there to maintain the capability.
Gyros, you get the telescope.
Yeah, pretty important. Yeah.
Right. So cut out right there. Explain what the gyros do, because they are an important part.
The gyros help control the pointing of the spacecraft across the sky. So if you don't have a sufficient number to operate the telescope, you basically can't do any science at all. So they're sort of the basic level of support that the telescope needs to move around and stay pointed at a particular direction on the sky. So that's why that got top priority over everything else at that point. Right.
It's very critical. So the first servicing mission, we put in a new camera, wide field planetary camera, ended up taking some amazingly humanity-altering images, and I'm not overstating it when I say it that way. There was also CoStar, which was the fix for the error in the mirror. Russ, can you tell us a little bit about what CoStar did, what it was?
Well, CoStar became a new requirement for our 1993 servicing mission. We had already been planning for it at launch time, but it turned out that we had to add something new, and that was a new scientific instrument that would by itself correct the optics going to the other axial instruments. And to our credit at NASA, we came up with a innovative, relatively simple way to solve the problem as best we could. And that was in the light path of this big scientific instrument to put in small mirrors that were trainable and allow corrective optics to the light path coming in to be passed on to the other instruments. And
now,
and we were successful in 1993 with that first servicing mission. But back at the time we launched in 1990, we didn't know how important that mission was going to be.
so you have a model there right next to you of the Hubble. Where was CoStar placed? You say in the light path. Where was it? Where was it put?
CoStar, well, first off, there are big doors that open up so that the astronauts can access 4 axial scientific instruments. So this particular bay door here is where CoStar was. We had sacrificed the original instrument.
So I was going to ask you, how'd you find space for it? Okay, so you took something out to put this in.
Take something out.
And yeah, actually, there's a question on Twitter right now from Daniel Fisher about this. Is that Hubble's high-speed photometer never got a chance and had to go for CoStar? Why did we never fly one again?
This all has to do with scientific importance and decisions as time went on. As we were leading up to 1993, the scientists had to make a decision as to which instrument could be sacrificed so that we could correct every other axial instrument.
Right.
Yeah, I think what it amounts to is that the high-speed photometer, although doing important science, was the least used of the scientific instruments. And if you were forced to get rid of something, the best thing to do is to go with the one that was being least productive out of the crew. It was a painful decision for everybody to make, but it seemed to be the right thing to do. And to answer your question about why it wasn't flown again or a similar instrument, every time we put a new set of instruments up, we had a competition where various groups in the astronomical area would get together and propose new instruments, and it just a photometer never rose to the top again in that very, very strict competition, very heavy competition. There were always newer and better ideas people wanted to invest.
Okay. Well, I don't want to go over all of the details of every servicing mission, but I would like to ask you, either Russ or Ken, I'll ask this to Russ, actually. Challenging servicing mission ever done on the Hubble Space Telescope. What was the hardest one? Was it CoStar? Was it the latest one? What was the hardest?
Overall mission, particular instrument. Hello?
I'm sorry. We were frozen. Hello, we're frozen. So.
It's good to answer both questions.
My question. Well,
most complicated instrument. Yeah, most complicated instrument and most complicated mission. Both of those are of interest.
Right.
Okay, complicated instruments were probably STIS and power control unit, and for different reasons.
What's the
power control unit?
What's that an acronym? STIS.
Space Telescope.
Tell us what STIS is.
I'm sorry. Tony, you're breaking up.
Space Telescope Imaging System. Yeah, so are you. We all are, I think.
And PCU is the power control unit was very critical because for the first time in its life, we had to completely shut down the power to the telescope. So I think a lot of us stopped breathing for a long. That was in
the power control unit was in the SM3B, so that's 2002-ish.
I'm sorry, 3B, yes. And it's the first time the power had been shut down. It was a tricky task as far as the astronauts were concerned, because we had 30-some connectors to take off, temporarily store, and then get back on, so that the electrical connections were made. And then we had to turn the power back on. Since power had never been turned off, it had never been turned back on. So those of us on the ground and the astronauts up there had a sigh of relief and proud accomplishment that it worked fine. Back around the SM2 time, astronaut tell me you will never be able to change out that power control unit. It was one of the units on Hubble that wasn't ever thought we'd be back in there doing anything with that. And there were other things on Hubble that, for reasons that make sense, you just couldn't change out. Power control unit was one of them. The astronaut told me he'd never be able to do it. It essentially set up a challenge to us. And guess what? From SM2 up to SM3B, we figured out a way to do it, and the astronauts did it. Power came back on. Hubble's still working.
Yeah. Wow. So I did not. So the power control unit just was never thought to have needed servicing. Why was that?
Well, the people at the time, first off, it wouldn't be a requirement that everything had to be replaceable. And looked at fault tree analysis, determined that there's probably a chance that that whole unit would ever have to be replaced. So it was on the list of things that necessarily was not expected to be replaced. It certainly could be, and we did, bolts and the mounting structure and all those electrical connections. Sure, we could do it, but it was a very tight space. It was not an easy task, either designing it on the ground, designing the replacement on the ground, and training the astronauts and having them do it in space.
So, Russ, I mean, in your story, talk about how you figure out how. I mean, this is required tools. Astronauts can't just take out their switch and replace the power unit. Requires very specialized tools. Talk about that a little.
Well, everything we did had a requirement for either replacement kind of repair, and as you mentioned, you just can't take up normal tools. Virtually everything we took up for Hubble missions had to be specially designed to consider safety, being able to complete the mission successfully, and the materials and the environment, so that there wasn't any grease that would be outgassing at the time. There weren't sharp edges. It had to withstand the changes in temperature. And in the case control unit, with all those electrical connectors on it, big circular connectors, we had to make sure we didn't either put too much torque or too little torque, either in removing or replacing. So we had all those challenges to make certain that mechanically and electrically it could be, the old one could be taken out, the new one could be put in, and it worked afterwards.
My favorite about that on this topic was SM4, when they had to design this bin, I guess, that John Grunsfeld had to use. They were unscrewing all these screws, and so to get all of those screws off without them floating around and becoming their own little satellites, they designed this thing that looked like a tackle box, and you screwed through it. You operated the screwdriver, and the screws and nuts or whatever they were fell into there, so they wouldn't be lost. I thought that was clever. I thought.
That was going to be the second answer to my question. The STIS, to your question, the STIS repair that we did in SM4 in 2009, and that we always planned for a nominal operation, and the nominal operation for that was to have this big blue plate that you're talking about, Tony, and a special tool that we built to be able to have that with, say, a screwdriver bit, go in for all the different fasteners, and there were over 118 fasteners or so, washers, fasteners, and have that actually.
Oh, look!
You mentioned it.
Yay!
Here it is. So that special tool reached through each one of these openings.
That's
Took
awesome.
out the fastener, the washer, whatever was with it, and essentially we made a sandwich. We designed this so it would be bolted to the plate that we're trying to take off to get to a circuit board on Hubble. So in that sandwich we had this outer plate. There are cavities in between here, so as each fastener came out, it floated within that cavity. And they went through with proper tools that were needed, got all of those off, and then this whole sandwich of this special plate that we designed and the plate on Hubble that we're trying to get to behind it were bolted together. And
Is that the actual one? Is the one you used?
Truth and I will tell you this is an engineering unit that we used in neutral buoyancy testing and training the astronauts. But with our video connection, you probably wouldn't tell the difference between the actual flight hardware and this tool.
Well, thank you for your honesty. Yeah. No.
So the first thing we did when we got it back on.
Go ahead and finish. Sorry.
The first thing we did. I'm sorry, Tony. Go ahead.
No, I was telling you to go ahead. We're all cutting out now.
Oh, okay. So the first thing we did was to count all those fasteners so that none would be floating loose, floating back down the barrel of the telescope, and they were all there. So this was the type of design that we had to go through to have a specialized design, designing this on the ground. It has to fit up there, and we went back through the drawings and the photographs to be able to tell all these dimensions that we had on this to make it work properly.
So this leads me to my next question, which is when you're working through these procedures for how to repair things on Hubble, you have a full mock-up of Hubble around, and you said in the neutral buoyancy tank, right? Is it? And then you practice your rehearsals there, correct?
Yes.
To make sure.
That's one thing we do. We have low-scale mock-ups that we put in the water, 6.2 million gallon swimming pool, essentially, down at Johnson Space Center in Houston, Texas. The astronauts go in on old suits. We take advantage of neutral buoyancy. We give them the tour underwater, and we go in on scuba and make sure that we know what they're doing and that they're doing the things that will lead to a successful change-out.
Great. Okay, so we're getting close to the end of the hangout here. I want to get to some questions. On the Q&A app, Cecil Morgan is asking, wasn't HST originally designed to be brought back to ground by shuttle for servicing? Ken, do you have any comment on that?
Yeah, originally that was the concept. I thought it might be brought back every 3 to, I guess, fixed up on the ground and sent back into orbit.
Happening.
We ended up not doing that for a couple of reasons. We ended up not doing that. One is you're breaking up, Tony. Can you hear me?
Yeah.
I know we all are. No, I can't hear you.
Okay,
I was asking you why that didn't end up happening. I was just asking why that didn't end up happening that way. Well,
right. In the end, people thought it would be actually too complicated and too expensive to bring the telescope down, refurbish it, and send it up. There was a lot of concern about possible contamination as the telescope was brought back down to the ground. There'd be, in addition to the chemical contamination, you have a lot of forces exerted on the telescope, both during reentry and relaunch, and the possibility that you'd shake things apart might in the end do more damage than you would gain advantage. So the idea of servicing in orbit sidesteps the contamination issue to a large degree and the additional stresses from launch. So there were also concerns that landing with the telescope in the back of the shuttle could be very dangerous if you had a unusually sharp deceleration of the shuttle landing at the airport, that the whole telescope might just come through the crew bay, and that was an undesirable event as well. So the whole pile of reasons, while we thought, well, it sounded good on paper, but it'd be much better if we just serviced it in orbit, and the techniques for doing that in orbit came along quickly enough that they were rapidly adopted, and we switched to the let's service it in orbit every 3 to 5 years.
Oh, okay. And
another reason, from an EVA viewpoint, we added solar arrays that no longer would allow the telescope to fit in the shuttle.
That's right.
We also put panels on the outside for thermal control. We put things inside, and it would have probably taken 2 or 3 trips of a shuttle to go up to bring back all the pieces that we added to it.
It's not very efficient, I guess. So
We'd love to see it. We would have loved to have it brought back, and we could go down to D.C. and see it in the Smithsonian, but that was not a practical way to do it.
Nah, it's too bad. It really is. Now, this isn't directly related to Hubble, but I think the shuttle was pretty much designed to land without anything in the cargo bay, wasn't it? I mean, did it ever land full of stuff? Do you know? Does anybody know? I mean, it's not a Hubble question exactly, but I'm just curious.
Well, it brought back LDF, didn't it? Long duration facility, I think, came back in the shuttle.
Oh, did it? Okay. I don't recall the.
No, that's probably not nearly as heavy or as dense as Hubble would have been, because it was basically an outer shell with samples of material all around the periphery.
But remember, for servicing missions, they take instruments up and they take stuff out, so it never comes back empty from a servicing mission.
That's correct.
Okay. All right.
Yeah, and as a matter of fact, a number of those instruments are down in the Smithsonian for folks to go and see.
Right.
Okay.
As well as CoStar, which allows you to see the correction that we made back in 1993 with the corrective optics.
So Eamon Fenton on the Q&A app is asking an interesting question. Would it not be a future option to have multiple smaller aperture telescopes like Hubble acting like an interferometer rather than a single larger telescope like James Webb? That's an interesting idea, sort of a series or a network of telescopes pointing up in orbit. What do you think of that, Kenneth?
Well, I think someone read my webpage, because I've actually worked on an idea called Stellar Imager, which was exactly that, basically 30 1-meter mirrors working together in space, all pointing at the same target at the same time and focusing light onto a central hub. And you could indeed, it would be kind of like a James Webb, which already has segments, but separating them out over much longer baselines. So instead of having a 6.5-meter diameter, you might have a virtual mirror that could be 500 meters or a kilometer in diameter, with a lot of open spaces between it. But you would observe an object and then move the mirrors around and kind of fill in that virtual mirror and get the resolving power on the sky of something a kilometer in diameter instead of 6 or 10 meters. And that something like that would actually allow you to resolve features on the surfaces of other stars. You could see spots and flares just like you see on the sun on very distant stars if you had something of that diameter.
That's that going. When's that launch? I guess I broke up.
It's probably decades off now. We know how to do it, but it would be a tremendous technology development. But it is possible. There's nothing physically impossible.
I would love to see something like that. I would totally love it. Okay, Scott, do you have any that I'm missing somewhere?
Not that I'm seeing.
Okay.
The ones from Twitter are mainly just awesome responses to the manned manned option for it. So let's see here. Yeah. Sand Archon says, "Wow, my daughter is going to freak when I relay this news." And again, because that would be an awesome job to grow up to want to be. I mean, talk about inspiring the youth of the future. Like, what do you want to do? I want to go man a telescope in space. That would be awesome.
I know, it would be a great job, no question about it. Well, I'm really sorry about all the technical problems, guys, but this will not be the only history hangout that we do for Hubble, because we just touched the surface on this one. So hopefully the technical issues won't be around the next time, and I'm going to invite both of these guys back again. And I also want to have Carolyn and I talked about this, we also want to have a hangout that's dedicated to the nuts and bolts of Hubble. How do we actually operate it? And so that's in the pipeline too, and hopefully these guys will join us again for that. I want to ask this last question to all of you, and Scott, I'd like to get your feedback, your reaction to this too. Can you give me, can each of you give me some comments on what the Hubble Space Telescope has meant to you personally. And I'll start with you, Carol.
You have Wallace with your brilliance.
Okay. Well, I came from the ground-based astronomical community, and we had some pretty good instrumentation there and did some interesting science. I think the Hubble then opens a lot of new areas of study. So technologically, I think the telescope is magnificent, and astronomers just love it for the technology and the amazing instrumentation on it, and the fact that, you know, every few years it turned into a brand new telescope. Somebody said this comment about, oh, you know, it's 25 years old. Yeah, but the last servicing mission was 2009, so it's really a 5-year-old telescope. So it's like fantastic, and the mirror is beautiful, even though it's not the perfect curvature. As Russ talked about, the ingenuity of the instrument building got around that, and now we can take full advantage of it. I also think that for Hubble, it changed a little bit the way people do science. The fact that we have large groups that collaborate, Frontier Fields is an example, Hubble Deep Field. Now all these other telescopes are working together. People who are using all kinds of facilities to look at specific problems in astronomy, which we never did before. So I think it changed the culture of science, and it's a magnificent telescope. It's just fantastic.
Thank you. Scott, can you give us some personal comments about what it's meant for you?
Yeah, I mean, and it's something that you and I have talked about privately, but, you know, I remember when Hubble launched, and I was fairly young at the time.
Whippersnapper.
Right, young whippersnapper. But so seeing and being excited about it, and seeing, you know, the beautiful images that have come down over time as I've grown up to really appreciate science and astronomy, and as it's become a more important part of my life, now to the point where I'm telling the story of Hubble through Hubble Hangouts. It really means a lot to me personally that I'm able to give back in this way, because it has really inspired me to learn more about our universe and being able to share that with people. So that's really how it's affected me, of watching the servicing missions and learning more and seeing a lot of the ultra deep field images and learning more and being able to share that with more and more people, and now even in a larger scope, now doing with Hubble Hangouts. So it's something that's really inspired me in many different ways. I love it.
Good, and you're doing great with the Hubble Hangouts too. I couldn't imagine doing these without you. So, Russ, you got any comments on from a personal nature on the Hubble?
Well, Hubble, working on Hubble from the EVA viewpoint, I personally have tremendous pride in how it has resulted. That you can talk to almost anybody and they know a little bit about Hubble. The tremendous accomplishments that it has made, and the images that it brings back. When I talk to school kids, their teachers don't like it, but I tell them to throw away their science books and their astronomy books. The kids all love that, and then so that I get invited back, I have to explain, I just got your attention by saying that. Don't you dare throw science books away. The impact that it's made on science, and to be a small part of the team of astronauts, scientists, engineers, technicians that NASA has put together to do this, I couldn't have asked for a better job.
Wonderful. And then Ken, I'll leave the last word.
It's been a fun ride. You know, who thought when I signed on to this for a couple of years back in the mid-'80s that it would have gone on so long. It's been a privilege to be able to stay with this observatory that's at the leading edge of science and has been there continuously now for 25 years, and that's only possible because we were able to do the servicing. Otherwise, we wouldn't have been able to stay ahead of advancements on the ground. But it's been a privilege to be here and be involved and watch all of the unexpected discoveries that were made, along with all the things that we thought Hubble would be capable of doing, helping to verify the accelerating expansion of the universe, which no one in their right mind remotely conceived of back when we were watching comets collide into Jupiter. There's a whole string of things that we didn't really anticipate, and it's been a whole lot of fun seeing them and being able to observe them and actually get real information out of them. So there's that, and then there's just the whole story of the lesson to be learned from never giving up and, being able to overcome adversity. First you had the spherical aberration, which looked like it was going to kill the mission, that we bounced back from very rapidly with a lot of talented people finding the solution. And then later on, when the last servicing mission looked like it was canceled and Hubble was going to stop operating, 2010 or something, we stuck with it, found a way to keep people employed and productive until the decision got reversed, and we got the last mission in 2009, which now looks critical for getting Hubble to operate, prolapse with operations with the James Webb Space Telescope. I think it's critical to have both of them up there at the same time in the sky, from the far UV, ultraviolet, bluer than the eye sees, out to the far red that James Webb will be able to detect.
Well, I couldn't agree more. And the public outcry from the last Hubble mission, servicing mission, was very humbling, and it was very amazing to watch the amount of support that the Hubble Space Telescope has.
Go ahead, Tony. I was just going to say, like, this, even we were talking about this service mission back in 2009. We're still putting out new information. We just released.
That's from today's press release.
That's from today's press release. I mean, just seeing the ghosts of these guys. So if you guys want to go to HubbleSite.org and check out today's press release with this brand new image that's come out there, and it's absolutely fantastic. And it's because we've been able to continue along and upgrade the telescope and stay wanting to do more science, that we're allowed to do even more discoveries like these and continue it going.
Nice. And I have often argued that the Hubble Space Telescope is probably the most important scientific instrument ever built since the telescope from Galileo, because I don't think there's a single instrument that has ever changed the course and the way we look at the universe more than that telescope has. And so, and it has literally changed my life. I can trace a path from the first time I ever watched the Hubble Deep Field in my career to here, and so Hubble has been an intimate part of my life ever since I first saw that first deep field in the mid-90s. Well, folks, I want to thank everybody. I'm sorry about the technical difficulties. That's it for this week, though. Next week we are going to have a hangout on on Hubble observations, which have been put together that have allowed astronomers to make a thermal map of an exoplanet. This is the temperature variations across the planet itself, and we're going to have the principal investigators involved in that science next week. So that's next Thursday, 3 p.m. Look forward to seeing you there. Russ, Ken, thank you very much. This has been a great hangout. I hope you'll come back and do another one with us, because we're not done. We're not done with the history of Hubble yet. So I hope you'll. Awesome. Thank you both very much.
Thank you. I want to have a hangout. I want to have a hangout from Russ's office. I think he's got a lot of cool stuff.
I know. We want
to hold it up. You know, look at this. Look at this. What's this?
How about this?
Yes.
That's one of my favorites.
All right, so I'm having a field trip from LA.
Yeah, absolutely. Thank you so much.
We'll have
it was
Russ move
great.
the camera around. Yeah, thank you very much, everybody. All right, folks, well, that's it for this week. Thank you all for watching, and as always, keep looking up.
Bye, everyone.
Space Telescope, the LST, which was supposed to be a 3-meter telescope, and that went along for a couple years. In 1974, basically all funding got cut by Congress, and there was a regrouping. People got together and worked with Congress and various politicians and the astronomical community to figure out what is reasonable. And out of that came that we know today, the 2.5 meters flown on the shuttle and in a mode that it could be serviced every 3 to 5 years.
So the idea I'm glad you brought up a good point about the atmosphere and being able to while the atmosphere does protect the sun and radiation. It blocks out some valuable wavelengths that we'd like to be able to see in astronomy, and so a strong case. And was the process back then similar to what it is now? Now we have these things called decadal, so not the most, and they are all ranked in order of priorities, or was it getting up on a soapbox and saying, I want a Hubble Space, I want a space telescope, I want a space. Hello?
Well, it wasn't.
Yeah.
You were breaking up, but there weren't the regular every 10-year studies that you were talking about. But there was a lot of both with the astronomical community and with Congress and the president to try to get new projects started.
In those early days, cost had to have been an issue on a cost versus the other things NASA was doing at the
Certainly, cost was a huge issue because people knew that Hubble wouldn't be cheap, and that's one reason it went from 4 meters down to 3 meters down to 2.5 meters, was to try to control the cost. But some kind of science that you would do with an orbiting telescope that would look at high energy events in the cosmos wanted to launch an X-ray satellite. The UV optical community, which is served by Hubble, wanted Hubble to do their kind of science. So there was trade-offs about which kind of telescope would be launched first, one would cost versus the other. So it was always a constant pressure to do it as cheaply as you could, but make sure it was big enough to do the science that you had proposed. Otherwise, it wouldn't be worth anything.
Guys, I need to apologize to everyone about this connection. It's not anything we can do about it, but I do want to apologize for the quality. We all keep cutting out, so please bear with us, and we'll try to do the best we can with it. Russ, let me ask you let me ask you a quick question here. In the early days of the design, did the design of the telescope, as you could tell, did it change much from the early days? I mean, was it what were some of the factors? Hello, everybody, and welcome to today's Hubble Hangout. My name is Tony Darnell. I work at the Space Telescope Science Institute, and it is great. We have a really interesting hangout planned. I think we're going to be talking about the history of the Hubble Space Telescope. Before I introduce my guest, though, I just want to say I better warn you, we've been having some technical glitches at the start of this broadcast. So if we start freezing and stuff, I think it's an issue with the Google Hangout system, so we hope you'll be apologies in advance if it gets really, really bad. So just wanted to say that.
Call for a Hubble servicing mission.
Yes, yeah. That's right. That's right. So, as many of you know, Hubble has been in orbit for 24 years now, taking data, and we're approaching it's approaching its 25th year. And this hangout is going to be the first in a series of hangouts that we do to help celebrate Hubble's 25 years in space. So this is the first one of those hangouts in that series. So we are excited to be able to offer this to you. If you want to, we hope you're going to give us comments and questions. You can do it on the YouTube and G+ event pages. We're monitoring those comments. You could also use the Q&A app that's on the video screen itself, as well as tweeting with the Hubble Hangout hashtag. So we hope to see some comments and questions for you, and we will look at. I'll read them out as the hangout progresses. So our guest today is
Goddard, but he was also
out again. I can see that already.
Could you hear that, or did it all disappear?
It froze up again. Yeah.
It all just froze up. I'm sorry.
Okay. Well, basically, I said that in 1923, a guy named Hermann Oberth actually wrote about launching an observatory into space and a rocket. He was looking for applications of rockets that they were starting to play around with. And 1946 was probably the seminal article about a space telescope. A professor named Lyman Spitzer at Princeton wrote for Project RAND, which was a think tank back in the 1940s, and he wrote an article about the advantages of putting an astronomical telescope into space, noting that you wouldn't be looking through the atmosphere, which blurs things out from the ground, noting you could see a broader wavelength of colors if you weren't looking through the atmosphere, and that you had a darker background. So that's really sort of the beginning of the idea of an HST. So way back in 1946, through the 60s, there were various conversations about Hubble in the 60s.
Oh, you're muted.
Okay, where people talked about what size telescope they might do, and it actually started out as a 4-meter telescope, the idea of launching it on a Saturn V rocket. So it was 4 meters on a Saturn rocket instead of 2.5 meters in the space shuttle, and we actually got there in pieces. Basically, in 1968, there was something called the Large.
We have some guys from the Goddard Space Flight Center. We have Russ Wermuth. He's the former EVA manager for Hubble, and he is now joining us to talk about some of his experiences with the Hubble Space Telescope. We also have Dr. Kenneth Carpenter. He is the operations project scientist for Hubble at Goddard. Welcome, guys.
Great to be here. Thanks, Tony.
Also joining me, as always, Dr. Carol Christian and Scott Lewis. Scott Lewis driving our internet for us. Thank you, guys. All right, so
today. The internet's driving itself, apparently.
I know. I really hope the doesn't get too bad. So so Hubble's been around for a while. I want to start at the very beginning, and I might mention that I think Carol, Scott, and I are going to be doing more of these Hubble Hangouts on the history part of it anyway, too. So I don't think that we're going to plan on trying to cover every single bit of the history of Hubble, but we are going to get to the focus primarily on the early parts. And so I guess, Ken, let me start with you. I'd like to ask, where did the idea of putting a telescope in orbit come from? Where did it originate?
Actually, the story for this goes back quite a way. I think the earliest suggestions of doing an orbiting space telescope were back in the 1920s, actually. There was a man named who wrote an article describing the possibility of launching an observatory into space on a rocket. He was more into rockets, just like Rob